Okay. All right, so let's talk about linear equations. In my opinion, this one probably should have come before the other ones, honestly. But we'll just deal with what we get as it comes. All right, so properties of inequality, of equality. So this is something we've already been doing. So if A equals B, we can say A plus C is equal to B plus C. So, and this little symbol here means if and only if. Or another way of saying if this is true, then this is true, or if this is true, then this is true. So both are equivalent. And here, if A equals B, we can also multiply by A equals B or times C. We can add it or multiply it. And that's almost always what we're doing. Usually when we're dividing or minusing, we're actually adding a negative or multiplying by a fraction is what we are. The reason this can't be 0, say if I have 3 does not, 3 and 4, and if I have 3 times 0 equal to 4 times 0, so 3 times 0 is 0, 4 times 0 is 0, so 0 does equal 0, but 3 does not equal 4, right? And so that's why C can't be 0, because then you can just break rules. All right, so a linear equation has the equivalent form, so we call this a linear equation. Oh, someone fixed it. Oh, good. So we're going to solve a bunch of these linear equations together. And so in order to solve this, the goal kind of is to get everything on all the variable on one side, all the constants on the other. And so here, in order to do that, I'm going to minus 2x from both sides. And I'm going to do the very first one, I'm going to do it very slowly. And so here I'll have x minus 3 equals 2. And then in order to get all the constants, so I put the x's all on this side. Oops. So I put all the x's on the left side. So I'm going to get all the constants or the terms without x's on the right. So I'm going to add 3 to both sides. And so here I get x equals to 5. And you can always check this, right? So 3 times 5 minus 3. And then we'll have 2 times 5 plus 2. Well, 3 times 5 minus 3 is 15. Minus 3 would give me 12. 2 times 5 is 10, plus 2 is 12. So 12 equals 12, so this checks out. Okay. In this case, sometimes you'll have to clear out your x. And so here we're going to add 2 to both sides. So I have 2/3 x on one side and 8 on the other. And then what I'm really doing here is most of you will write divided by 2/3, divided by 2/3. But what you're really doing here is I'm multiplying this side by, and the entire side by 3/2. I'm going to multiply the entire side over here by 3/2. Why? Because that clears my fraction, makes this x equal to 1, because this 2 cancels this 2, this 3 cancels this 3, so I'm left with x. This 2 cancels this and makes it a 4, so I have x equals to 12. And we just check that real quick. So 2/3 times 12 equals 6. So here I cancel this out. I cancel this out, and I'm left with a 4. 2 times 4 is 8, minus 2 is indeed 6, so 6 does equal 6, and so we're good to go. All right, so go ahead and try C and tell me what x equals. And then I'll do D with you. And I'll wait until I have about 4 or 5 of you answering before I move on. And let me get rid of someone's grades, because dear goodness, if I show someone's grades, I'm going to go to purple jail. You won't see me no more. All right, so you get x equals 3. So let's just go through that. So here I'm going to minus 3 to both sides. X. And here I'm actually going to do both steps at once. I'm going to add 4 to both sides. So 7x minus 3 would gives me 4x. Negative 4 plus 4 gives me 0. Negative x minus x is 0. And then x plus that gives me 12. Here I'm going to divide out forward by both sides. What am I really doing? I'm really multiplying by a fourth. But you just divide out 4 from both sides, and you get a 3. Okay. Now, if you see something like this, what you're going to want to do is distribute. The first thing you want to do is distribute. So you're going to move in the 2. So I'll have 10. So 2 times 5 is 10 minus 6x equals 8. We're going to move in the negative 3. So this will be minus 3x. Move in the negative 3 into this. So that'll be minus 6. And so the first thing you want to see is distribute. Please, please, please notice that you have to pull in the negative with it. So this becomes negative, this becomes negative. And the same thing if this was, let's just give you another quick example. If this was 5 minus x plus 3, here I have to pull in the negative here and here, and this becomes 5 minus x minus 3. So even if you see a negative with no number here, pull in the negative. This is probably one of the more common problems I see for this class, is that you don't move the negative in. Here, we're going to simplify out. So here, this is simplified, so I'll leave that as 10 minus 6x. This here, 8 minus 6 gives me 2 minus 3x. And I'd like to keep my my variable positive, so I'm going to add 6 to both sides this time. So that's 0 here, so I have 10 equals 2. Negative 3, so this would be plus 3x. Move the 2 over. Did I do something wrong, or does this one just end up being awful? I can't read that. Which one can't you read? Oh, C and D. Okay, yeah, let me zoom in. That will clear up my thing. We don't need this right now. I'm going to write this a little cleaner. So I'm going to minus 3x plus 4 minus 3x plus 4. So this becomes 4x 12 divided by 4 divided by 4. X equals 3. Here, I distribute. We're going to keep this clean, so this will be 6x minus 6. I'm adding 6x to both sides. There we go. We get to this point. We're going to minus 2 from both sides. We're going to move this up here. So I'll get 8 equals 3x. And so here x equals 8 thirds. When I divide it out. Okay, and so here we get x equals 8 thirds, and then we'll just check it in. So let's pretend I did all the work and I want to check it in a different way. Is there other ways we can check this? Oh, sure, right? So all of you have a calculator, so let's just go to Wolfram Alpha with the calculator, right? So here I got 8 thirds, and I really don't feel like typing in or crunching all these fractions in my head, but I want to make sure if I got it right or not. So here we're just going to type in the left side. We're going to have 2 times 5 minus 3x, which for x here we're going to type in 8 divided by 3. And see what I get. Close that off. I get this to be minus 6. So that's good. Let's check the other side. It'd be 8 minus 3 times x here is 8 divided by 2. If not an 8. Divided by 3, sorry. 8 divided by 3 plus 2. And that gives us also -6. And so we get the same answer. -6 equals -6. And so that's just a way of checking it. Okay. All right. Let's go ahead and pull this off. Zoom on. Oops, zoom on out for a second. All right. So one of the things you're going to have to do later in life is to solve equations for a given variable. And I'm going to work through both of these with you. And then I'll have you guys do one. We may do this as more practice. So I want to solve an equation for a given variable. So here, if I want to solve for little m, I'm going to try to move everything over to the other side. And so in order to do that, I'm going to have, let me write this here so I have more room, equals big G, little m, big M over r squared. Does anyone know what this is? What this is the function for? For A? It's a scientific function. No. This is the force of gravity. This is gravitational force, gravity. So the force of gravity is equal to the gravitational constant times the little mass, and most of the times, like, plus the bigger mass divided by the distance between them squared. And so that's where this comes from. If you want to solve for your little mass, say you know what the force is, and you want to figure out what the little mass is, this is what you'd be doing in any science class. So in order to do this, I'm just going to multiply both sides by everything else kind of flipped. So here I'll put big M here, and I'll put a G here as well on the bottom. And when I do to one side, I must do to the other. So here, big M and a G. So this G crosses out this G, the R squared crosses out this R squared, the big M crosses out big M. And so here I'm left with the force times R squared over big M G. Make that a little bit more like a G. Is equal to M. And here's another equation. This is the area, the surface area of a box. So length. So you'll have 2 length times width. So these will be the sides. Width times 2 length times width will be the top and the bottom. 2 width times height would be 2 the sides, and 2 length times width would be the other 2 sides. So this is the surface area of a box. If I want to solve this for W, in order to do that, so I want to solve this for W. So this is still linear in the sense that this is always nice and clean. I'm going to move, so this doesn't have a W, so I'm going to move that over. So A minus 2LH is equal to 2LW plus 2WH. And let me use a cursive L for this problem. All right. Then notice here I can factor out a W. H equals 2L plus 2H. And then I'm pulling a W out of both. So here I can distribute in, and I also can do that backwards. I can pull out a W, I can pull out a W. Then all I have to do is divide both sides by this quantity, and so I'll get A minus 2LH over 2L plus 2H. That looks more like a 2. This is equal to W. So this is just some practice on doing stuff. How could you put the G in the fraction? Oh, so notice here that if I have, that's a good question. I like this question. Notice here if I have G times M over R squared, that is the same thing as G times M over R squared. Because here if I multiply, it's kind of like if I multiply 6 times 7 force, right? This is the same thing as 6 times 7 over 1 times 4. So this is the same thing as putting 6 times 7 over 4. So if you multiply a single entity, you're just allowed to throw it into the numerator. Okay? That makes sense? All right. I don't think the homework really stresses this too much, so I don't think you have to worry about it. I can double check in a second, but let's go to the next page. All right. All right, so here's something you just need to be aware of. And then we're going to do, I think we just do 2 word problems and we're done. Yeah, we just do 2 word problems and we're done. Okay. You'll get a lot of practice of this. I'll write up a couple of these for Thursday practice. All right, so every now and then some equations have no solution. Let's take this one, for example. So let's take this one. And this is just easier seeing. If I add 24x to both sides, right? Well, 24x here, that zeroes it out because I'm trying to get all the x's to this side of the equation, right? So I'll add 24x to this side. But notice that that zeroes out this as well. And so here I get 0, here I get 0. I have 7 equal to 17. Well, that's never true. It's just not, right? And so in this case, this has no solution. So you just write no solution. Oops. I didn't want to do that. I'll just write no solution. Okay. Same thing happens here. Notice if I add or if I minus 12 to both sides, I get nothing. And so I'll have 25 equals to minus 8. So this also has no solution. Some equations can have, if I have 2x plus 1 equals to 2x plus 1, notice that this solution here, if I minus the 2x from both sides, I get 1 equals to 1. That's always true. Sorry, I'll make that a little clearer. This is always true. And so if it doesn't equal each other, there's no solution. So no solution, no solution. This means you have infinitely many solutions. AKA anything I put into x makes this work. If I put 3 into x, it works fine. If I put 5 into x, it works fine, right? Because this is the same expression. So you can have no solutions, you can have infinite solutions. All right, so your book goes over how to solve, how to do properties of equality. It's basically how to solve some of these, right? So familiar stuff. This is just how to solve problems. I'll write that. I'll just rewrite this as how to solve problems. Just solve word problems. Not all problems can be solved with math. So familiar yourself with the problem, make it rhyme, find further information, assign variable, organize it into a chart, write a list, guess or estimate an answer. All these things are good. I should add spaces between these. I'll go up and update that later. Then you're going to try to translate into mathematical language of symbols, carry out some sort of math manipulation, check to see if the possible solution actually fits the problem solution. And say, this is all just a real thing. Basically, it says, try to figure out what the problem's asking. All this is figure out the problem's asking, draw pictures, assign variables, make it easier for you. Write an equation. This would be write an equation. And then all this just really means solve it. And then since it's a word problem, since it's a word problem, you write it in complete answers. All right, so let's talk about the motion formula. So there's 2 formulas in this. So the motion, the distance d traveled by an object moving at a rate. So the distance, which is given by d, of a moving object at a rate, so rate or speed, right? You can change this word out for speed if you like. In a given time t is distance equals rate times time. And so here's one of the things you might see, right? This is like a word problem I stole straight from the book. All right, so we have an American Airlines going. West Airlines, including a Boeing 737-200, and each at a cruising speed of 500 miles per hour and has a cruising speed of 600 miles per hour. Suppose that this one takes off and travels at its cruising speed, the other one takes off an hour later and follows the same route traveling at its cruising speed. How long does it take for the 7 to overtake the dash 122? So what is all this? Hold on, let's just sort all this for a half second, right? Are all the numbers in this problem important? Let me ask that question. Are all the numbers in this problem important? No. Like, is this number here important for my equation? No, right? Yeah, labels what it is, but it's not a number I'm going to chunk through an equation. So sometimes they have red herring numbers. You're like, okay, this number is not super useful, right? It's not super useful. So let's write down. Let's just simplify ourselves. Let's simplify ourselves. Let's just call this one. So what do we have here? What do we have here? We have the Boeing, right? Let's just make this real. Let's just call this the Boeing, and the other one is the dash. Let's just say Boeing and dash, just to keep our lives easier, right? Boeing and dash. The Boeing travels at 500 miles per hour. So let's just say 500 miles per hour. The dash goes at 302 miles per hour. So the dash takes off and then the Boeing comes an hour later, right? So if we're going to go in time, so let's just say time t equals 0 is when the Boeing leaves, right? The Boeing plane leaves. So the time for the Boeing, it will be in time. And then the time for the dash will be t plus 1. Why? Because it had an hour head start. It says, so the dash left, and then 1 hour later, the Boeing left. So here, this will be t plus 1, because I've had an extra hour. And since this is miles per hour, hours make a good sense for our time for this, okay? So here I have my rate, here I have this, and I want to know, and so the other thing we have so here we're using distance formula. Here's my rate, here's my time, and here's my distance, right? And some distance, d, which I do not know, they'll meet up with each other. And I want to know when these distances are the same, right? Because for here, the distance I've traveled is given by 500 times, t, right? That's an ugly 5. So the distance I traveled here is 500 times t. The distance I traveled for this one will be 302, because that's my rate, 302 times t plus 1. And so this is often how you do these problems. If you have one and one leaves later, when do they meet, right? And so here, the distance needs to be the same. So the distance needs to be the same. So we just set that equal to each other. So let me create me a little bit more room real quick. Let's get rid of this, let's get rid of this, let's get rid of this. And I'm just going to set these two equal to each other. 500 times time equals 302 times time plus 1, okay? So at zero time, the dash is 302 miles away. We want to find out when this becomes the same time, so we just solve. I'm setting t equal to 0 is when Boeing leaves. So I'm setting when time is 0, right? I could have done it the other way. I could have set it when the dash left, right? And if I did that as when the dash leaves, that means the Boeing loses an hour, right? The Boeing is an hour behind, but I'd like to start time equal to 0 and not have negative distances. And so that's why I did that. Does that make sense, Liz? You have to set your 0 point for time. Okay. So you had two options here. I like to have positive numbers, and so that's why I did this. All right, so let me just solve this equation. Well, how do we solve this? We just so we set it equal to each other. So the first thing I'm going to do is distribute this 302. I'll have, let me zoom in so I have more room because I can only write so well. All right, so here I'll have 500 t equals, that look like that, t equals 302 t plus 302. Then I'm going to minus 302 t from both sides to get all my t on this side. And I get 302 minus 500 be 198. Yes, I think. Equals 302. And then I just divide this out. So 198. So that cancels 198. That means t is equal to, oh, whatever that awful number is. Let's figure out what that awful number is real quick. All right, let me just type that in. It's approximately, hold on, let me go back. Just chunk this through a calculator. You guys know that this symbol means approximately. Where you see the little wavy lines. Yeah, okay, so this is approximately 1.53. And so you just say it's 1.53. We'll just, you can check it. Just seeing how we're almost done with class, I'll just tell you it's correct, right? So this is, so we say, and so to answer this correctly, which I won't write because I ran out of room. I should have left more space for this. To answer this correctly, it says, how long does it take? You'd say it takes approximately 1.53 hours for the 737.2 to overtake the -1 of that. That's what you'd write. Okay. All right. We're gonna go a little bit longer, just for 2 seconds, and then we'll go shorter next time. All right. So let's just talk about simple interest formula. This is simple interest, where oops, I missed my little things. Hi. What's going on? There's more than one layer. Oh, hi, thank you. I was like, what's going on? So this is your interest. This is your principal, or the amount you put in. This is the rate, how much you're being charged at. And this is your time, right? And so let's just say, we'll just do a quick one real quick, and then we'll call it a day. So we'll go like 5 over today, and we'll be earlier next time. All right, so Jared has 2 student loans for a total of 120 bucks. This is another popular exam question they love to ask. One loan is at 5% interest rate and the other is at 8%. After 1 year, Jared owes this much, 750 in interest. How much is in each loan? So this is the same thing. I'm debating if I want to do this now or just do it with you guys next time, because I don't want to rush through this. You guys just want me to finish this notes and spend 10 minutes on it and then end early next time, or just call it good now because technically class is over? And yeah, let's just do it now. Okay. All right, let's just do it now. I don't want to rush through it, but I do want to do this thing. So this is a super popular one. So let's write down all the information. We know we earn this much interest over time, right? So we want to figure that out. So let's figure it out. So I want to figure out what's the amount in each loan. So that's the goal. I want to know how much is in each loan. So let's write down all our things. So let's have our interest. Let's have our principal. Let's have our rate. Let's have our time. And we're going to have this for my 5% loan. We're going to have this for my 8% loan. And we're going to try to figure this out. All right. So the time. So after 1 year. So this is time in years. So after 1 year. So both of these will have the one time. This is interest rate, but when you put in interest, you can convert it from a percentage back to a decimal, right? So this would be 0.5 and this would be 0.8. Okay. The principal, we don't know how much we put into each, right? However, and this is, but we know the total, but we know two totals, right? We know that we put 120 into both of them, right? Because that's how much I have taken out, right? So that's 100 or 1,200, sorry. Or no, not 1,200, 12,000. That is 12,000. This is 12,000. And I know that the interest for both of them is 750. So these are things I know. All right, so in order to do this, I'm going to just say I put in X amount into 1. So I'm just going to say X is the amount I put into, let me clean this up. I'm going to say I just put an X into the 5% loan, right? If I put X into that, and if I add these two up, I get 1,200. That means I had 1,200 or 12,000 minus X in that one. Does that make sense? If I put some amount into X amount into the 5%, or if I took out X increment, and I know they add up to 20, so or 12,000. So if I take 12,000 minus it out, that's what must be in the other one. Okay. And so here we can crunch through what the interest is, right, as a formula. So this one would be this times this times this. So this gives me 0.05x. The interest here is this, so interest equals principal times rate times time. So here would be this times this times this. And so here I have 0.08 times 1,200 minus x. And I know this adds up to be 750. So let's actually do that. So now I can write out an equation. 750 is equal to the interest of the first one, 0.05x, plus the interest of the second one, which is 0.8 times 1,200, or 12,000 minus x. And then all I need to do from here is solve it. So let's solve it as best we can, because these two need to add up to this column. It's kind of convoluted to put it all together, but it's always put together the same way. And so when you do this, when you do 2 or 3 problems of this, you'll just get used to doing it. Okay. All right, so let's crunch this through. So let's just move this in and move this in. So here I'll have 750 equals 0.5x plus 0.8 times 1,200. I have this one pre-done in front of me, so this is 960. So 0.8 times 12,000 is 960 minus 0.8x. All right, so if I put these two together, so 0.5 minus 0.8 gives me 750 minus 0.03x plus 960. I'm going to minus 960 from both sides. And I'm going to get hold on, 120 minus 0.03x. Then I'm going to divide by minus 0.03. You're going to chunk this through a calculator. You're not going to do this by hand. You can, but you're going to chunk it through the calculator, and you're going to get x is equal to, hold on, x is equal to, so negative 210 divided by negative 0.03. That'll give you 7,000. So x is 7,000. If x is 7,000, so that's the amount in the 5% account. So the amount in the 10% or the 8% account is what? Well, it'll be 7,000. So it'll be 12,000 minus the 7,000, because we know what X is now. And so that is 5,000. And so you have your answer. Yep, 5,000. So here, Jared took out 7,000 at the 5% and then 5,000 at the 8%. And then you just type that in. So I'll have another one of these on that. And then the very last thing for this notes is just the zero of a linear function is when you plug in a value, you get 0 out. And so that's useful to know. At times we'll solve for such things, but that's it for the notes for the day, guys.